All right. This video, I want to show you what to do for creating a refutation. What is a refutation? A refutation is kind of like determining the validity of an argument. If I determine that an argument is valid, I say that if I make the assumption that the premises are true and the conclusion is false, I will result in a contradiction. However, if I make that assumption and I don't have a contradiction, what I will be left with at the end of the day is truth values for some of my terms that, if that is the case, then the conclusion doesn't necessarily follow. And we call that the refutatio, or the refutation. If you've heard seniors talking about doing their thesis and they're preparing some of their refutatios, that's ultimately based off of this simple idea. All right, so in an argument, if I was to give you, say, A entails B, C or B, therefore C or A. If I wanted to figure out if this is valid or invalid, we would start the way that we're going to start all of these problems off, by assuming that the premises are true and bracketing off the conclusion, and instead assuming that the conclusion is false. So I'm ignoring C or A, and I'm saying let's just assume that it's not the case that C or A is true. And let's figure out what happens after that assumption. Now, the first thing I should do is start at the top and say, okay, what kind of statements do I have? I have an if statement, I have an or statement, and I have a nor statement. If statements and or statements are both I types of statements. They require an I rule. I can come up with an inference from them. But for this one, I'm going to either need to affirm A or deny B. And for this one, in order to get any information, I'm going to need to deny one of them. But I don't have any simple premises anywhere, or I don't have anywhere that affirms or denies any of those things that I would need to affirm or deny. However, nor is helpful. It is one of those overpowered rules. It's an S rule. And so I'm going to say, let's start that bracket and recognize that if it's not the case that C or A is true, it must be the case that C is false and A is false. And I know both of those because of line 3, and I applied the nor rule to both of those. And now I have a little bit more information. I'm going to star that because that's broken down. I can ignore this. And say, oh, I needed some of that information actually. I knew that if C was false, then B must be true. So let's check that out. Let's say line 6. If C is false using the or rule, then B must be true. And I applied lines 2 and 5 together using the or rule. And now at this point I can star this. And so if I wanted to write those simple terms too, I can recognize that 4, 5, and 6 are all simple terms. And I might look back and say, okay, can I do anything with my one remaining proposition? Well, not really, actually. Remember, I would have to either affirm A or deny B. Well, I've denied A and I've affirmed B. And so this, in the future, would be one that it wouldn't be a bad idea to think maybe I should make a second assumption. This one is a little funny, though, because we're only dealing with simple terms right here. And a second assumption would end up just necessarily resulting in a contradiction of one of those assumptions. So we're not going to ultimately do that because it wouldn't be profitable to do it. Instead, we're just going to recognize we have the values for A, B, and C. We haven't hit a contradiction. And so I'm going to write my refutation. I'm going to say that given that A is false, that B is true, and that C is false, I have a certain truth value of all of these claims in which it's not the case that this conclusion necessarily follows from this. Now, here's where I should be really cautious. Because like I said, normally I would want to make another assumption that ended up breaking down this first line. I'm aware that right now the first line does not filter into my refutation. So one of the ways that I can help with that is I can just simply plug these truth values in as little exponent forms. And I can say, all right, let's plug these values in right here. And let's see if it is true that I can have two true premises and a false conclusion, right? So let's think, what is the truth value of a false claim entailing a true claim? Well, false claim entailing a true claim is actually true. I say it's 1, it's true. It's exactly what we want it to be. A false claim or a true claim. That, once again, is true. If I say that either this claim is true or this claim is true, and this claim is true, then the whole relationship would be true. Well, what about a false claim and a false claim? That is false. And indeed, that's what we're wanting to find. We're wanting to try to find 2 true premises and a false conclusion. So I've demonstrated with my refutation that if A is 0, B is 1, and C is 0, then this argument that I made up here can be demonstrated to not necessarily imply the truth of the conclusion, even if the premises are true. In other words, I've just refuted the argument. All right, so hopefully that makes sense. Next, I want to work through making an argument with multiple assumptions, which I think would actually be a better way of doing this argument. I will move to that one in the next video, and you can just jump straight to that.